There are a range of different measures of portfolio evaluation that are used to determine the success or otherwise of an investment. In this learning objective, we are going to look at the application of Sharpe ratio, M-square measure, trainer ratio, Jensen alpha, and the information ratio as measures of portfolio performance. So first of all, the question, why do we go about evaluating portfolio performance? Well, it's important for us to evaluate how our asset perform for two reasons. First, we look at portfolio evaluation as the way of backtesting prospective investment strategies. So one way that we can help to determine whether or not that appears to be a sound scientific basis for investment philosophy is to use historic data to backtest the performance of that strategy. Portfolio evaluation also has a second purpose. That's to test and report investment performance. Particularly in the delegated fund management industry, there are regulations that require the reporting of performance of particular funds. But even of individual investors, it's important to identify how investor has performed and potentially feed that information into the continual reworking and improvement of the investment strategy. So when we go about evaluating performance, there are a range of different measures that we might use. We can use measures that in all instances are looking at a trade-off between risk and return. However, there are different ways that risk and return are measured across those different evaluation measures. So first of all, the first group of measures look at mean variance measures. In these measures, they are looking at the trade-off between returns and risk, and the risk is measured by standard deviation of returns. So those measures are Sharpe ratio and M-square measure. The second group of measures look at the trade-off between returns and risk, where risk is measured as beta. We call them CAPM measures, and those measures are trainer measure and Jensen alpha. Another group of measures look at considering risk in terms of downside risk, given we previously seen that investors may be more concerned about downside risk as opposed to upside potential. So these measures are Sortino ratio and risk-adjusted return on capital. And finally, investors also often engage in benchmarking, whereby they compare their performance to some pre-identified benchmark as a way of controlling risk. So first of all, the Sharpe index or the Sharpe ratio. So here we have got a pure risk and return trade-off where our numerator, you can see, is the excess return generated by the portfolio, or the portfolio returns minus the risk-free, the rate of return, and the denominator is the standard deviation of returns generated by that portfolio. So basically what we are looking at here is that a higher Sharpe ratio implies better performance. Now, a Sharpe ratio is just a ratio, you understand. The ratio itself does not have economic meaning in the sense that it gives us a measure of the degree of our performance. The Sharpe ratio can only be used for comparing investments. That is, the higher Sharpe ratio, the better the investment. However, it does not tell us the degree of underperformance or overperformance. An alternative measure that allows us to use the standard deviation as a measure of risk, however, has the added benefit that it can give us a measure of the magnitude of performance, is the M-squared measure. So basically what the M-squared measure does is that it takes the managed portfolio, the portfolio you evaluate, and it combines it with the risk-free rate in order to calculate a hypothetical portfolio that has the same risk as the market, where the risk is measured as standard deviation of returns. Now, if you look at this equation at the bottom, which is M-squared measure calculated, it is better to think M-squared measure intuitively. Basically, what we do is we take our risky portfolio and we weight the risky portfolio by the ratio of the standard deviation of market to the standard deviation of the portfolio. You can see it here. What we are doing here is we are either leveraging our portfolio up if it is less risk in the market, or we can buy into our portfolio if the risk-free rate, with the risk-free rate, if our risky portfolio is more risky than the market. Therefore, we adjust the overall level of risk to be equivalent to market. And then with the balance, you can see it here, the balance 1 minus the ratio in the risk-free rate. Okay, so we take the combination of these two. We have effectively created a new portfolio that combines a risky asset and the risk-free rate together. And as I said before, the relative weightings are determined such that this new portfolio will have the same standard deviation as the market. We then subtract the market return of the end, and what we have effectively done is when compared two portfolios, we have the same standard deviation, and the difference in returns between our hypothetical portfolio in square brackets and the market return will give us the degree of over or underperformance. Let's think about this numerically. Let's imagine we have a managed portfolio that has a return of 35% and standard deviation of 42%. And let's imagine that we have a market portfolio for the same time period, which has a return of 28% and standard deviation of 30%. And let's assume that the bank bill rate, that means the risk-free rate, is 6%. We could have calculated the Sharpe ratio the way we have done previously. And remember, Sharpe ratio is return less the risk-free rate divided by standard deviation for both. And just based on the Sharpe ratio, we can see that the market actually outperformed our managed portfolio, because the Sharpe ratio of market portfolio is 0.73, where the Sharpe ratio of managed portfolio is 0.69. Now the M-squared measure will give an answer in the same direction as the Sharpe ratio, but it goes one step further because it gives us a measure of the degree of over or underperformance. So what we can see here, our managed portfolio had a higher return in the market, but it was also quite a bit riskier. So how do we compare these two? Well, we create a new hypothetical portfolio combining our managed portfolio and the risk-free rate, and we create that hypothetical portfolio such that it has the same standard deviation as the market. So as discussed earlier, the way we did that, we do that is that we weight our hypothetical portfolio so that the weighting in our managed portfolio is the ratio of the standard deviation of the market over the standard deviation of our risky portfolio. So over 30 divided by 42, it comes from the previous slide. This 30 divided by 42 is 0.714. It's the weight of the managed portfolio. And we put the balance, 1 minus 0.714, that's 0.286 is the risk-free rate in bank bills. So the return on this hypothetical portfolio, the expected return is, you can see, is the weight times the return on our managed portfolio, which is 35%, plus the weight in the risk-free rate, 6%, which was the return on the risk-free rate, and the return on the hypothetical portfolio is 26.7%. But we have now created a hypothetical portfolio that has the same risk as the market, and this is, by construction, has the same standard deviation as the market. So what we can actually do is we can just compare the returns. The return on the hypothetical portfolio less return on the market portfolio after controlling for risk, we can see is minus 1.3%. So it indicates that our managed portfolio has actually underperformed the market by 1.3%. So another way to think about this is that if we look at the capital allocation line, which is the trade-off between expected return and standard deviation of any asset, we know that we have got the slope of the capital allocation line is the Sharpe ratio. As the Sharpe ratio is the expected excess return divided by standard deviation. Now we have got these two portfolios. P is the managed portfolio and M is the market portfolio. And M squared measure is equating them. So moving this P back down to this capital allocation line, we're combining it with the risk-free rate such that it has the same standard deviation of the market. Our M squared measure is just been the difference between these two. Okay. If our portfolio overperforms the market, what we might have found that this line would have been perhaps was up somewhere here, and then we combine it with the market, we end up with a value that is above, and after controlling for risk, in that case, we would have found that our asset had outperformed the market. The next measure we look at in terms of evaluating performance relates to a CAPM measure. Now, what we are looking at is the trade-off of expected returns and risk, where risk is measured as beta. So the trade-off measure, first of all, is very much similar to Sharpe ratio, because numerator is the return on the portfolio minus risk-free rate. So this is excess return, but the denominator in this case is beta. So just as a Sharpe ratio, higher trainer measure means better performance. We can use the trainer measure to compare relative performance of stocks. Okay, so what we are looking at here is the security market line. We can compare the security market line of various stocks where we plot excess returns on one axis and beta on the other. The steeper the slope of the line basically means a higher trainer measure to compare assets. Now again, one potential problem with the trainer measure is that it does not give us a measure of the magnitude of outperformance. So a way that we can measure the magnitude of outperformance by using beta as a measure of risk is Jensen alpha. Jensen alpha is an adaptation of the CAPM model, whereby it says we can estimate the expected return that a stock should have generated given its beta using the CAPM model. We can see here in square bracket that we have the risk-free rate plus beta times the return on the market minus risk-free rate, that is expected return. The return we expect to generate given the risk-free rate plus the systematic risk and risk premium. And we can compare this return with the actual return on the portfolio, that is here. So here is that the return we actually generated less, here's the return which are generated given the risk we are talking about. So Jensen alpha gives us a measure of the difference between those. Hence, once again, it gives us a measure of risk-adjusted returns. The next group of measures look at the downside risk as a measure of risk. So once again is the trade-off between return and risk, but here we are focusing on a different type of risk. So the first is the Sortino ratio. Once again, look, the ratio looks quite similar to the Sharpe ratio. The numerator is still the excess return, that's the return on the portfolio minus risk-free rate, but the denominator here is the downside deviation. So what we mean by downside deviation is that it's the standard deviation of all returns that are less than the mean. So what we are looking at here is the spread of only those opportunities that are the danger side of the danger and opportunity risk trade-off. Just the downside returns, and in that way it's actually partially picking up for the effects of skewness as well as the effects on part of variance. An alternative way to look at a measure of downside risk is to look at the value at risk. And the value at risk gives us a measure of the observation that we get in the worst n% of occasions. We look at, this is a 5% part, which is a return value in the 5th percentile or the bottom 5% of returns. So with the risk-adjusted return on capital measure, once again, the excess return into the numerator, however, denominator is the difference between the return on the portfolio and the 5% bar. The 5% bar being the 5th percentile of outcomes that we have achieved, or that covers the point to where we start to get to the 5% of worst case scenarios. Now, once again, this is giving us the difference between the mean return and the 5% bar is giving us a measure of downside risk of the distribution. So once again, denominator here is a downside measure of risk. and we have got excess return on top, downside risk as the bottom to get our risk return trade-off. We mentioned earlier that an alternative to looking at these measures of risk-adjusted return is benchmarking. So benchmarking is a technique whereby we say, well, the calculation of risk is quite opaque and quite difficult, so let's do away with it. Let's instead just equate the return of portfolio of the return of some benchmark portfolio that is pre-identified. The idea of that benchmarking should have an equivalent level of risk to our asset, and hence all we can do is we can just compare the return of the two assets because we have effectively eliminated any concern with risk because we are comparing two assets that have equivalent risk. So we then find that the manager's contribution is the difference between the portfolio return and the benchmark return. Now, most commonly, we find that investment managers will use a market index as a benchmark. So in Australia, for example, they will use ASX 200. That might be relevant in some situations, but the question is it relevant in all cases? Well, to answer that, we have to think about what are the characteristics of a good benchmark. So a good benchmark should be investable. It should be something that can actually be replicated. It should be having an unambiguous composition, so you should know how the benchmark is actually constructed. We should also know that in advance, it should be appropriate, and it should have an equivalent risk to the risk of the asset that's being compared to. It needs to be specified in advance. So a benchmark needs to be identified upfront. You can't fit a benchmark to evaluate your performance after the fact. That's basically a cheating. And it needs to be objectively constructed so it can't be tilted in favor or against any particular manager. The last consideration in terms of looking at measures of portfolio evaluation is to consider the information ratio. The information ratio is a way of measuring the performance of an active investor. Active investing versus passive investing has both benefits and costs. The benefit of active investing compared with just passively investing in a market index is that you've got the potential to outperform the market. You have got the potential to generate a positive alpha. If you are just holding the market, you can never outperform the market. Similarly, you never underperform the market as well. So the benefit of active investment is ability to generate alpha, but the problem with active investment is that you may become less than perfectly diversified. So a perfectly diversified portfolio is holding the market portfolio. Hence, through active investment, you are exposing yourself to unsystematic risk. So what we find with the information ratio is that it trades off the benefit and cost of active investing. So our numerator here, you can see we have got the benefits, which is alpha, the ability to outperform or an abnormal return, and denominator is the measure of unsystematic risk. So higher the information ratio, the better the active investor has actually performed. So it's a range of different techniques that can be used for evaluating the performance of your portfolio. And it's also important that you pick up an appropriate performance evaluation measure to evaluate performance of your portfolio. That's the end of discussion on Learning Objective 2. Please watch the next video for our discussion on Learning Objective 3. Thank you.